All right, let's take a look at number 4. So the formation of water, according to this equation right here, 2H2s plus O2 react to form 2 H2Os. This equation shows 2 molecules of hydrogen, which are made of 4 atoms of hydrogen, because hydrogen is a diatomic molecule, and 1 molecule of oxygen, which again is made up of 2 atoms of oxygen, diatomic, produce 2 molecules of water. The total mass of the product, water, is equal to the sum of the masses of each of the reactants, hydrogen and oxygen. What parts of Dalton's atomic theory are illustrated by this reaction? And what fundamental law does this reaction illustrate? Now, this question right here is hitting in broad strokes the big points that we're supposed to be covering here in section 1. The fundamental laws, okay, the law of definite proportions, law of multiple proportions, law of conservation of mass, and then Dalton's 5 postulates that describe his atomic theory. So, what are we seeing in this equation? Well, we are seeing atoms combine in simple whole number ratios to form compounds. Hydrogen and oxygen both are diatomic molecules, meaning when they exist as pure substances, it's not just one atom of hydrogen or one atom of oxygen. It's O2. When you breathe in air to get oxygen out of the atmosphere, you're not taking in single, lone oxygen atoms. You're taking in O2 molecules, okay? 2 oxygens bonded together. Same thing with hydrogens. Also, we see water. Everyone knows that the chemical formula for water is H2O. But what we see there is a combination of different elements in simple whole number ratios. The ratio here is 2 hydrogens for every 1 oxygen. Okay. Also, since we see that the same elements that are present in the reactant side, the left side of the reaction arrow, are present in their same forms on the right side, on the product side of the reaction arrow. Now, I don't mean that they're the same substance. I mean that they're still the same element. Hydrogen has not been transmuted into helium, and oxygen has not been transmuted into fluorine or nitrogen or something else close to it on the periodic table. The identity of the elements themselves has stayed the same. All we've done is rearrange them. And so what this suggests is, because we're not changing the identity of the atoms, is that atoms cannot be subdivided, created, or destroyed. Now, we now know that's not entirely true. If we are privy to a nuclear reaction, those things can happen. They can be subdivided. But we're not talking about nuclear reactions here. We're talking about chemical reactions. And so those are the 2 postulates from Dalton's atomic theory that we're seeing here that are in play. Atoms cannot be subdivided, created, or destroyed. Also, atoms of different elements combine in simple whole number ratios to form compounds. Now, as far as the fundamental law that this is illustrating, it's illustrating the law of conservation of mass. And you can tell because if you count the number of hydrogens on the left side of that reaction arrow, you're going to get 4. And then when you count the number of hydrogens on the right side of that reaction arrow, you're also going to get 4. When you do the same process for oxygen, you're going to get 2 oxygens on the left side of the reaction arrow and 2 oxygens on the right side of the reaction arrow. And so we see that the exact amount of matter that was present on the left side is present on the right side. One can say that the mass here has been conserved. It has been saved and not lost.